Bismillahir Rahmanir Rahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this video I'm going to discuss a few past paper questions for International A-Level Edexcel M1 Mechanics. Particularly we are covering the questions of, pulleys, specifically chapter number 4, either the basic case of the pulley or the pulley on the horizontal table. So we are doing some past paper questions accordingly. So here we have handout question number 22. Okay, this handout is basically for chapter number 4, the dynamics of particles. So here we have question number 22 of the handout, which is GCE M1 June 2013, question number 8. So the question says that two particles A and B have masses 2m and 3m kg respectively. The particles are attached to the ends of a light inextensible string. Particle A is held at rest on a smooth horizontal table. The string passes over a small smooth pulley which is fixed at the edge of the table. Particle B hangs at rest vertically below the pulley with the string taut as shown in figure 2. Particle A is released from rest, and assuming that A has not reached the pulley, find the acceleration of particle B. Okay, so we have a smooth horizontal table over here. Particle B is heavier as compared to particle A. So obviously system will come down, meaning particle B will come down and particle A will move towards the pulley. Okay. So basically we need to find the acceleration of the particle B over here. Okay, so first I'm going to mark the forces. So I took a screenshot of the picture and I labeled the forces over here. When I'm referring to particle B, so the tension is moving away from the particle B. When I'm referring to particle A, so the tension is moving away from the particle A. Okay. And the weight of the particle B will be 3 mg Newton, which will be acting vertically downwards. And weight of the particle A would be 2 mg Newton, which is also acting vertically downwards. However, particle A is in contact with the surface. Okay, so there will be a normal contact force acting on the particle A, which is opposite to this weight, according to Newton's third law of motion. Okay, so first thing first, what we need to find the acceleration of the particle B over here. Okay, so when we make the equation of motion for particle A, so T will be equals to 2ma, because in the opposite path there will be no friction, as you know that this horizontal table is smooth. Okay, so when we are considering the forces horizontally on this particle A, so there is only this force T, which is the tension in the string. So according to Newton's second law of motion, net force is equals to mass times acceleration. So there is only the force of the tension in the string which is pulling this particle A towards the pulley. So T will be equals to 2ma. Okay, and when the particle B is coming downwards, so 3 mg will have a higher magnitude as compared to the tension in the string. So 3 mg minus T will be equals to 3ma. Okay, because 3 mg minus T, this will give us a positive value of acceleration. So 3 mg minus T will be equals to 3ma. This is the equation of motion for particle B. So as we want to find the acceleration, we are going to eliminate the variable t over here. So in place of t, I will substitute 2ma. Okay. So 3 mg minus 2ma will be equals to 3ma, which means 3 mg is equals to 5ma. So m and m got cancelled out. Mass got eliminated. So therefore acceleration is equals to 3g divided by 5. Either you can leave your answer in an exact form in terms of G, or you can just write the value correct to 3SF by using the value of G as per the instructions of Edexcel M1 Mechanics. Okay, so acceleration correct to 3SF is this value. But when the requirement of the question is to find in terms of G, so then you need to leave your answer in terms of G. That's compulsory in that particular scenario. Okay, then we have part B. In part B, we need to find the tension in the string. Okay, we need to find the magnitude of T. So T is basically 2ma, and in place of acceleration, we are just going to write 3g over 5. So either you can write your answer as T is equal to 6 mg over 5, or you can use the value of G over here. Okay, so T is equals to 11.76 m, correct to 3SF 11.8 m. Since we don't have enough information to find the mass of the particle, so we will leave our answer in terms of m over here. So either you can write T is equal to 6 mg over 5 or 11.8 m, correct to 3SF. So this was part A and part B. Now in part C, it is asked to find the magnitude and the direction of the force exerted on the pulley by the string. Okay, so for that purpose, we will discuss this part C on the next page. So basically, what is the required force over here? Since you know that we need to find the force exerted on the pulley by the string. The string is basically above the pulley, okay? So the force which is exerted by the string on the pulley, this is the required force. So here I have marked this force over here. Force exerted on the pulley by the string, or you can say by the string on the pulley. So this force will act over here halfway between the two tensions in the string. Okay, this force would act as an angle bisector of these two tensions over here. Okay, so when we are basically considering the pulley, meaning when we are basically referring to the pulley, so the tension in the string is moving away from the pulley, because tension moves away from the point of reference. This is the pulling force over here. So when we are considering the pulley over here, so the tension in the string is moving away from the pulley. Okay, so either you can do head to tail rule, or we have a standardized formula over here. We have a standardized formula over here in order to find the force exerted on the pulley by the string, or if it is asked, force exerted on the string by the pulley. In both cases, magnitude is basically found in the same way. So here is basically the standardized formula: 2 multiplied by T multiplied by cos theta over 2, where theta is basically the angle between the two tensions. So a detailed explanation along with the basic scenario, basic examples, I've already provided enough detail in my online classes. Okay, but just for the sake of this video, I'm going to discuss this thing briefly again over here. Okay, I'll make a sketch from a scratch. Okay, so here is the pulley on the edge of a horizontal table. We are considering these two forces. One T is going over here and one T is basically going over here. All right. So first thing first, if you use head to tail rule, so basically one force is picked up and placed on the head of the other force. Basically, the tail of one force is placed on the start of the other force, on the head of the other force. This is called head to tail rule, or you can say nose to tail rule. Okay, so according to the vectors addition law, this force, which is basically the sum of these two vectors, this force will come like this in this path, and this force will be the required force which we are required to find, and this will be the resultant of these two forces, which you can just mark R or you can mark as F. Okay, so one way is to do this, because we are dealing with a case of the pulley where the pulley is on the edge of a horizontal table. And one more thing which you need to understand over here is that angle between the two tensions is 90 degrees. So the angle between the two tensions over here will also be equals to 90 degrees. Okay, these two tensions are perpendicular to each other. Okay, so basically we have a right angle triangle over here in which one adjacent side is T, opposite side is also T, and R is basically the hypotenuse. So you can just use R square is equals to T square plus T square, meaning R square is equals to 2T square. This means R is equals to square root of 2T square, which will leave you with under root 2 multiplied by T. So whatever the value of the tension in the string is, you just multiply it with under root of 2 and you will get your answer. This is basically one way to do this. Okay, and here I have explained this in detail over here. All right, and the other way which I've mentioned first. This is the standardized way. This is basically the standardized way which can be used in all of the cases of pulleys. Literally in all of the cases of pulleys. Even the basic case as well, where the two particles are hanging vertically. Okay, so I'll just explain this thing from scratch as well over here. Okay, so basically, here we have the pulley, and here is one force T and the other one over here. So particularly in this approach, we are not dealing with head to tail rule. We are keeping the forces as it is, as they are acting on the pulley. Okay. So what's happening is that wherever the forces are acting, they are placed over there. But what we are going to do, we are going to resolve the forces over here. Okay. And basically the force which we need to find is acting halfway between the two tensions over here. Okay, we need to find this force, and basically this force is comprising of two components. Okay, and since you know that these two tensions are perpendicular to each other, and this force is going halfway between the two tensions. Okay, so this angle is also 45 degrees and this angle is also 45 degrees. So the component of the force which is adjacent to this angle 45 degrees, this will be T cos 45. Okay, I'll make the pen more thin. Just give me a minute. T cos 45 degrees, and this force as well, this will be adjacent to this angle 45 degrees. So this will also be T cos 45 degrees. Okay. And basically the force which is opposite to this angle 45 degrees, this will be T sine 45 degrees in this path, and T sine 45 degrees over here in this path. But we are only concerned with this force which is acting from this point halfway between the two tensions. So basically what I've done is that I have broken this tension in the string force in two components. And the same thing I did for the T force acting over here. Okay, so this approach is basically called resolving the forces. Okay, so how do you identify this? Okay, here is basically the starting force of this point. Only just consider this T force over here. So the path of this T force, the alternative path of this T force is that first you come from here to here and then you go like this. So this is basically the addition of these two vectors, and here you get its resultant, which is T. Okay. So basically the force which is required to find is this force, which basically comprises of these two components, T cos 45 and T cos 45. So both will be added together. Okay, so we are going to say that T cos 45 degrees plus T cos 45 degrees. Okay, which means 2T cos 45 degrees. Okay, and since the value of cos 45 is under root 2 over 2, so this 2 and 2 gets cancelled out, and therefore you are left with under root 2 multiplied by t, which is the same thing which you obtained earlier. Okay, but my purpose over here is to tell you that we have a standardized way to solve this thing in all the cases of the pulley. So first you always make a sketch in this way. Okay, and then you just mention this formula 2 multiplied by t multiplied by cos theta over 2, where theta is basically the angle between the two tensions. This is basically a hack to solve the questions like this. Either you are required to find the force exerted on the pulley by the string, or the force exerted on the string by the pulley. If it was required to find the force exerted on the string by the pulley, so this would be this force, which is acting in the opposite path but with equal magnitude. Okay, So here is basically the formula to find the magnitude of these forces. All right. It depends on the context of the question, the wording on the question, where the force is actually acting. In this case, force exerted on the pulley by the string. Okay, so a string is above and pulley is underneath. So here is the required force in this particular question, in this particular scenario. So I hope you understand this sketch from scratch which I have made. I'm going to erase this. Okay, and I've already solved the question over here. Okay, these are the notes from the classwork of my online classes. So basically, I'm trying to make maximum recordings in English for my YouTube channel. So this complete concept is already discussed in my online classes with my students before starting the past paper questions. Okay, so this is 2 multiplied by t multiplied by cos theta over 2. You need to remember the heck. This is the formula which you need to remember, and here you just make a basic sketch where theta is basically the angle between the two tensions. And since we have found the magnitude of the tension in the string, which was 6 mg over 5, so I've just used this. Okay, and remember that theta is the angle between the two tensions. Since the two tensions are perpendicular to each other, okay, so angle between the two tensions is equals to 90 degrees. Okay, so 2 multiplied by 6 mg over 5 multiplied by cos 45 degrees. And since the value of cos 45 is root 2 over 2, so 12 mg over 5 multiplied by root 2 over 2. This will give you 6 root 2 over 5 into mg Newton. Okay, and alternatively, head to tail rule concept, r square is equal to t square plus t square. So r is equal to under root 2 into t. So under root 2 multiplied by 6 mg over 5. So 6 root 2 mg over 5. However, we need to also tell the direction of the force. So here I've just mentioned some description halfway between the two tensions downwards. Okay, even if you don't mention this description over here, this sketch would also be enough for you. But still I have made a statement over here. Okay, for the safe side, it's good to write a brief description like this. However, we have made the sketch over here and we have also marked the angle and we have also marked the arrow over here for this particular force. Okay, so halfway between the two tensions which is acting downwards. If it was asked that the force exerted on the string by the pulley, so this would act upwards in the exact opposite path with same magnitude. Okay, so this is basically the whole idea behind this. All right, so this was basically question number 22 of the handout, GCE M1 June 2013, question number 8. And as I said earlier, this particular method 2 multiplied by t multiplied by cos theta over 2, where theta is the angle between the two tensions, is applicable on all cases of pulley. So I'll just give a brief illustration for this over here as well. Okay, for the purpose of this video, let's say you have a pulley on an inclined plane. On the edge of an inclined plane, you have a pulley and one particle is over here. Okay, and one particle is hanging like this. Okay, so let's say the inclined plane is inclined at an angle of theta degree to the horizontal. So let's say theta is this angle. Okay, all right, so obviously this horizontal and vertical are perpendicular to each other, so this angle is basically equals to 90 degrees. Okay, so let's say we have the angle between the two tensions as alpha. So now we consider this angle alpha. And how to find angle alpha? 180 minus 90 minus theta. And then we can say that 2 multiplied by t multiplied by cos alpha over 2. And here alpha is basically the angle between the two tensions. All right. Let's say we have a case of two inclined planes. Let's say we have a case of two inclined planes. And this is basically the angle between the two tensions, which is theta. So one t is over here and one t is over here. Okay, but you might be wondering that angle between the two tensions is obtuse. So how come this is possible? Because when obtuse angle is divided by 2, this gives you an acute angle. And the cos of an acute angle, the cosine of an acute angle is always a positive value. This makes sense. Okay, so even if this angle theta is obtuse, which is between the two tensions, so even if this angle theta, which is between the two tensions, is obtuse angle, so cos obtuse angle divided by 2, when obtuse angle is halved, this gives you an acute angle. So this will also be applied 2t multiplied by cos theta over 2, where theta is angle between the two tensions. Let's say you have a horizontal table over here, and here you have an inclined plane. Okay, and pulley is on the edge of the inclined plane. One particle is on the rest, and one particle is on the inclined plane over here. In this same case, theta would be an obtuse angle, which is between the two tensions over here. Again, you can apply this 2t multiplied by cos theta over 2. Remember that the angle which is basically inside this cosine, this is halved, and this theta is basically the angle between the two tensions. And now you might be wondering, how come this is applicable in the very basic case of the pulley where the particles are hanging vertically? No problem. Okay, let's say the particles are hanging vertically. Okay, so as you know that in the book examples, you have seen the basic case, and the force which is exerted on the pulley by the string is 2t, because this is t plus t. So how come this is 2t? Because 2t multiplied by cos theta over 2, and in this case, the theta, the angle between the two tensions, is 0. So theta is equal to 0, and since you know that cos 0 is 1, so 2t multiplied by cos theta over 2, and in place of theta, I'm going to write 0. So this will give you 2t times 1, which is 2t. So this hack is basically applicable in all cases of the pulley. You just need to write down the formula, and you just need to make a very basic sketch. So this is basically the whole idea behind this. All right. So for the purpose of this video, I've just give some detailed explanation over here. Okay. Otherwise, I have discussed all of the things in detail in my online classes with my enrolled students. So if anyone is struggling out there, so you know where to contact. Okay. So now let's move forward. Let's move on to another question. So I thought just to give some brief explanations over here for this lecture in English. So up next is January 2025, question number 7. So the question says that here we have a basic case of the pulley. Okay. So the question says that one end of a light inextensible string is attached to a particle A of mass 2 mkg. The other end is attached to a particle B of mass 3 mkg. The string passes over a small smooth fixed pulley. The string is taut and both straight parts of the string are vertical. Both particles are held at a distance of 0.5 meter above a horizontal surface as shown in figure 4. The system is released from rest and B moves downwards, because B is heavier as compared to A. So when the system is released, B will come down and A will go up. Okay, so part A is asking find the tension in the string in terms of M and G. Okay, so in this particular question, it is a requirement to leave your answer in terms of M and G. If you don't do so, you are going to lose your accuracy mark. Okay, so basically, um, first I marked the weight of the particle, which is 3 mg Newton. When I'm referring to the particle B, so the tension in the string is moving away from the particle B. And when I'm referring to particle A, so the tension in the string is moving away from particle A. And here we have the weight of the particle, which is 2 mg Newton. Okay, so when we write the equation of motion, so particle B is going down, so 3 mg would have a higher magnitude as compared to the tension in the string. So therefore 3 mg minus T will be equals to 3 ma, and since particle A is going upwards, so T will have a higher magnitude as compared to 2 mg, so T minus 2 mg will be equals to 2 ma. So in part A, as we want to find the tension in the string, so I'm going to eliminate the acceleration over here. So A is equals to T minus 2 mg divided by 2m, and A is equals to 3 mg minus T divided by 3m. So A is equated with A, and therefore I equated these two expressions with each other, and therefore I obtained this equation. 3T minus 6 mg is equal to 6 mg minus 2, and therefore the tension in the string is 12 mg divided by 5, or you can say 2.4 mg. This is the answer of part A, which we are looking for. Okay, so now let's move on to the next part. In part B, we need to find the speed of particle B at the instant it strikes the surface. Okay, so the system is released from rest. So initial speed, initial velocity will be 0. Particle B will cover a distance of 0.5 meter when it strikes the ground. Okay, and acceleration we are going to find over here. Acceleration we can find over here now, since in part A we have found the tension in the string in terms of mg. Okay, and we need to find the final speed. So first I found the acceleration. So I used the equation of motion of the particle B. Even I can use the equation of motion of particle A as well, because both will have the same magnitude of acceleration. Okay, so acceleration is equal to 3 mg minus 2.4 mg completely divided by 3m. So therefore acceleration is g over 5, because mass will get cancelled out eventually. Acceleration in terms of g, we have obtained g over 5. Okay, and then uh, since the particle will cover a distance of 0.5 meters, so the displacement is taken as 0.5 meter, and we need to find the final speed, final velocity. So v square is equal to u square plus 2as. U will be kept equal to 0 because system was released from rest, obviously. So v square in terms of g, we have obtained g over 5. Okay, therefore we are going to find the value of the speed. So v is equals to under root of g over 5, and I've used the value of g over here. So therefore the speed is 1.4 meter per second. Okay, this was a requirement for part B. All right, so now let's move on to the next part. Here we have some story before part C. Let's see what the question is saying. It says that in the subsequent motion, A does not reach the pulley and particle B does not rebound after it strikes the surface. So basically, when particle B strikes the surface, it does not rebound. But when particle B will cover a distance of 0.5 meter below its initial position and will strike the ground, so particle A will also cover zero point 0.5 meter above its initial position, and particle A will experience the slack in the pulley. I mean, there will be slack in the pulley, due to which particle A will freely go upward under the motion of gravity, and then particle A will hang again. Okay, so there will be slack in the pulley and particle A will go above, particle will go upward freely under the motion of gravity due to slack in the pulley. So part C is asking, find the time from the instant when the system is released from rest to the instant when A first reaches a height of 1.06 meter above the surface. Okay. So what you need to understand, 1.06 meter above the surface, particle A will reach 1.06 meter above the surface. Particle A and B are initially on the same horizontal level. Okay, and they both are zero point 0.5 meter above the horizontal surface, above the horizontal ground. So what we are going to find, we are going to find the point where particle A reaches a height of 1.06 meter above the surface. Okay, so zero point 0.5 meter is the initial distance. Then particle B will cover zero point 0.5 meter when it strikes the ground. So obviously particle A will also cover zero point 0.5 meter above its initial position. So zero point 0.5 plus zero point 0.5 will give you 1. After this slack in the pulley will occur, Okay, and the journey which is due to slack in the pulley, so that string will not remain straight and the string will bend and there will be slack in the pulley, and due to slack in the pulley we have left with the remaining distance, which is 1.06 meter minus 1. So this essentially means that the distance of the slack in the pulley journey is 0.06 meter. So when we are considering the slack in the pulley journey, so particle A will cover a distance of 0.06 meter. Okay, so this is basically the whole idea. So first of all, I'm interested in finding the total time before the slack actually happens. Because we need to find the time from the instant when the system is released from rest to the instant when A first reaches a height of 1.06 meter above the surface. Okay, first time it reaches a height of 1.06 meter above the surface. So first of all, we have before the slack in the pulley, because this is basically the duration, the journey of the particles when particles are in connection with the string. Okay, so when the system is released from rest, so initial speed, initial velocity is 0. Acceleration is equals to g over 5, and the final speed, final velocity is 1.4 meter per second, as we have already found in part B. Okay, so v is equals to u plus at. So in place of v, I kept 1.4, u is 0, and acceleration is g over 5. So time is basically 5 over 7 seconds. Okay, this is basically the duration before the slack in the pulley. All right. And then we have slack in the pulley journey, the instant when slack happens. So after the slack in the pulley, the initial speed will be 1.4 because the final speed of before the slack in the pulley will become the initial speed for after the slack in the pulley. And due to slack in the pulley, particle A will cover a distance of 0.06 meter, okay, above this point. And this is basically not the highest point of particle A, okay, because the highest point would be something above. Because at the highest point above the ground, the final speed will be 0. Here, if we try to find the final speed by considering this much distance of slack in the pulley, so we would have the speed something other than 0. Okay, so this is basically the idea behind this. So slack in the pulley, when the slack in the pulley happens, so initial speed is 1.4 seconds and the distance we are considering is 1.06 minus 1. Okay, and we need to find the duration, and acceleration is basically due to gravity, which indicates that the particle is decelerating as it is freely going upwards under the motion of gravity, vertical motion. Okay, because when you consider the equation of motion of particle A, okay, when you consider the equation of motion of particle A was going upwards when there was connection with the pulley. So T minus 2 mg is equals to 2 ma, and when the slack in the pulley happens, so tension in the string becomes 0. Okay, the tension in the string becomes 0. I hope you have covered all of these basic concepts. So this 2m and 2m gets cancelled out and acceleration is minus g. Okay, so this basic working is not required at all over here. You just need to use the fact that acceleration will be minus g. However, this working would be quite helpful for you when you are considering the pulley on an inclined plane, or you can say two inclined planes, or you can say on a horizontal table, okay, or you can say one horizontal floor and one inclined plane. In those cases, the equation of motions would be quite helpful. And it would depend that inclined plane would be rough or smooth. Okay, so in those cases, it would be quite helpful to use the equation of motion of the particles when you are going to find the acceleration value, which is due to gravity. But here we are considering a basic case of pulley where the particles are hanging vertically. So what I'm trying to say is that we are going to use this information and we are going to use S is equals to ut plus half at square So in place of s, we have mentioned the value. And here we would be able to obtain a quadratic equation in terms of t, which I have just used the quadratic formula in the very next step. And here I have obtained the two positive values of t. Why there are two positive values of t? Because particle A has not reached its highest point. This is not the highest point. Highest point would be something somewhere over here above this A complement point. Okay, I've just mentioned this A complement point because I'm considering this journey to this journey as a slack in the pulley, but this is not actually the highest point of particle A. Okay, I've explained this thing on the next page as well. I haven't explained. Okay, I'll explain it over here. That basically, you know, particle A, when it goes freely under the motion of the gravity. Okay, so let's say this is the highest point. Okay, let's say this is the highest point. And if this is the highest point, so particle A will go freely under the motion of gravity and a string will bend. And after reaching its highest point, particle A will come down again and it will hang again. Okay, at this highest point, the final speed, final velocity would be zero. But here in this case, this slack in the pulley journey is just considering this much distance, which is 0.06 meter. Okay, so when we have two positive values of t, so when particle A is going upwards, this is the first positive value of t which we are obtaining. Okay, and then we have another positive value of t because particle A will go up at the highest point and then it will come down. So the displacement will again become equal to 0.06 meter. Okay, so assume that this distance is basically x. So the displacement would be something like this, that 0.06 plus x minus x, which will again give you the same value of the displacement. So basically when the displacement, as you know that these SWOT equations, SUVAT equations, these are basically all of them are vector quantities except for time. The displacement, initial velocity, final velocity, and acceleration all are vector quantities, okay? And we use these vector quantities in order to obtain the scalar quantities in order to find the answers for the scalar quantities as well. Okay, so displacement is basically equals to 0.06 meter. So here we have two values of t. Okay, so what I'm trying to say is that the first positive value of t which you have obtained, this will be your answer because question is saying that find the time from the instant when the system is released from rest to the instant when particle A first reaches a height of 1.06 meter above the surface. So the smaller value of t will be obtained and the higher value will be rejected. Okay, this is the first positive value of t because time is always positive. Here, after solving this equation in terms of t, you are getting two positive values of time. So the first one will be considered. First positive value will be taken over here. And the second positive value will be this one at this instant when particle A will be coming back. So we are going to accept the smaller positive value of t and the higher positive value of t, which is the second positive value. This will be rejected. Okay, this is the whole idea behind this scenario. All right, so I'm going to just erase this. All right, so basically the higher value of t is going to be rejected. All right, and the smaller value will be taken over here. This will be taken as the duration of the slack in the pulley. Particularly, the question is asking that the instant when A first reaches a height of 1.06 meter. This is the first time particle A reaches a height of 1.06 meter, and this t value, this value of t 0.233208. This is the second time when the particle A is reaching a height of 1.06 meter above the surface after coming back from its highest point. Okay, so the total time which we are looking for, one time is before the slack, which was 5/7, and the other time is after the slack, which is 0.05251. I've taken the value to a higher degree of accuracy and I've added these two values. So 0.7668, meaning correct to three significant figures, 0.767 seconds. This is supposed to be your answer. All right. So in this way, we have attempted this question, which was January 2025, question number 7. So for the purpose of this video, for the sake of this video, I have recorded these two questions. I'll be uploading more content. Stay tuned to my channel. Thanks for watching. Assalamu alaikum.